So just to recap, okay, we were discussing about dimension modeling, star schema, and Snowflake star schema. So maybe people are already aware of this. I'll just fantastic. Okay, star schema, you will have a single fact table and multiple dimensions will be surrounded. Every fact table contains measures. Measures means your calculatable columns or metrics or columns which can help you to understand how your business is running. So generally these are called metrics. Okay, sometimes these columns also popularly known as the key performance indicators. So which will help you to tell how your business is running. Typically every fact table, whatever measures we are calling, where we store in fact table, okay, usually they will be in numerical only, so that because you can say sum, you can say average, you can say min, something like this. Okay, and other tables are dimension tables, and your dimensions will be storing all textual attributes, your product ID, product description, okay, product category, student ID, student name, okay, student gender, or if you take a date, what is the month, year, quarter, all is generally textual attributes. Okay, and when you are creating the tables and then you are building the model, okay, the tables like this, and in this model, in the star schema, every dimension table will be completely denormalized. If you see here, we have one fact table and every fact table surrounded with one dimension table, but after this dimension, so there are no other tables, okay, related to this dimension table, because when we have a table, we will have some columns, and these columns we can store into a single table, or we can also split into multiple tables. Okay, but in this star model, every dimension table is completely denormalized. Okay, that's why. So example, you already seen. So I have a customer information, I am storing ID, name, their address, all the information, anything related to customer, I will keep into a single table only. And means one way we are doing complete denormalization of one particular dimension table. So that's why this is called star schema. Okay, and at the same time, we can also have dimension tables created in a normalized structures. Okay, it means that, so same customer table previously what we had, and one dimension table I am splitting into two dimension tables here. So previously all this information have kept into single table, but right now I have split into two tables. Means splitting means technically normalizing. Okay, so when you create tables like this, you will lose the star diagram, because I have a fact table, one dimension, another dimension, I am joining with other dimension, but if you see this dimension table information, I can keep into one table or I can split into multiple tables. So I am just splitting into multiple tables here. So that's why we will lose the star behavior, star diagram here. Okay, so you can take any example. So this kind of modeling technique is called Snowflake star or Snowflake model. So diagram wise, star or snowflake will look like this. Looking at the diagram, you can easily tell or identify which is star schema and which is snowflake schema. But technically when you are explaining what is star schema means your dimension tables are fully denormalized. When you say snowflake, technically dimension tables are normalized to some extent. Okay, it's, we cannot, because I don't know, like one dimension table I can split into one or more than one table, or sometimes, okay, in this scenario one table split into another table, that further split into another table. Okay, and that's why technically when you say snowflake, your dimensions are normalized to some extent. So what is there is no benchmark how much normalization you have done. So it depends on the requirement. Okay, your data modeler will create. But whenever you have seen this kind of modeling tables, that we will generally call as a Snowflake model. Okay, so example, putting all together, star, Snowflake, and multi-star. So multi-star you don't need to specially discuss. Putting all the stars together, okay, is called multi-star. Okay, I have in the star Snowflake, when we are talking, there will be only one fact table. You see, I have only one fact table. All are dimensions. And here also I have only one fact table. Remaining all dimensions. But in the multi-star also popularly known as galaxy. Okay, because you have multiple stars in the sky. So we'll call it a group of your stars, we'll call it as a galaxy. So in the same way, we'll call it as a multi-star, or some people also call it as a galaxy schemas. Anything, but it is not very much important because putting all together, okay, so some of the dimensions, okay, will be common, okay, to this fact table, this fact table. Some dimensions may not be common, they will be independent to fact table. So that all generally style of data model creation, table creation, it will be, but very important is what is differentiating the star and Snowflake, because that will be your first question when you go for interview. Okay, is your project is built on Snowflake or a star? So what is star, what is Snowflake? So for both people, ETL and reporting people, this is your first technical question, I can say, because the remaining all the background, why building warehouse and all, okay, this we have already seen it. So now we know that dimension tables, fact tables, okay, what it will contain, what is star, what is Snowflake star, okay, and yesterday we started discussing about, okay, once you create a dimension table, what are the columns you will keep in your dimension table. So we have seen couple of examples also in the dimension table. You can have on average, when you say, even sometimes right now not required to discuss, but at the end of the course or end of the once you start attending your interviews, okay, what is important is generally people will ask you how many dimension tables you have in your project, how many fact tables you have in your project, whether you work on a ETL or a reporting, because we are going to use those tables. If you are an ETL guy, you will be loading into these tables. If you are a reporting guy, OBIE guy, you will be generating reports from these tables. So people will ask you how many fact tables you have in your project and how many dimensions we have in your project, okay, which you are working. So that we can discuss later, but on an average, you can say maybe 100, 150 dimension tables in a bigger, medium to bigger scale project, and you can say 30 to 40 fact tables in an on average. There is no fixed or benchmark that, okay, you should have only these many tables in any project, but a medium scale average project, what we can say is like we have like 100, 150 dimensions, okay, including smaller and bigger, and your fact tables, you can say 30, 40 fact tables you have in your project. But what are the tables which you are working, you can limit, okay, I am working only on these 10 tables, okay, I am only working on this. That anyway in the project I can explain you. But generally, what are the expected potential questions from this particular topic is how many dimensions you have in your project, whether they are built in a star schema or a Snowflake star schema, and how many fact tables you have, okay, all that generally a common interview question. And also in the same time, you will also very commonly nowadays question, what is your size of data warehousing, okay. So for mid-scale projects, right, you can say 2 terabytes is your project. Nowadays, volumes are growing, and maybe you'll see 50 terabyte and 60 terabyte data warehousing project. But if you go and say 50 terabyte, you will get a lot of questions like how do you do performance tuning and all. So that's why you can restrict yourself to 2 terabyte to 2, 3 or 4, like on average 2 to make it less than 10 terabytes so that you will be comfortable. Okay, these are common questions nowadays. People are asking either in a technical interviews or in a management. Like once you finish your technical rounds in a managerial round, so they will generally ask you how many tables you are working and all. So that's why keep in mind. We'll discuss it later again. Okay. So when we are creating this table, I'm just recapping because there are a couple of people. Yes, they want to understand clearly. So what is the dimension and fact again? So everything is a table only. So there is nothing great. Okay. So to easily identify, okay, out of so many tables, which is a dimension, which is a fact. So every when we are creating the tables, we can follow, okay, certain naming conventions. So for dimensions, so if you see all the dimension tables which I have created in this project are ending with _D. So if I see a table with _D, okay, I can understand that this is a dimension table. Okay, and all the fact tables in this project. So it is not mandatory that everywhere you should have same names. Okay, but I am just showing an example generally how we follow. So this is one of the live database. Okay, so all the tables ending with F are fact table for me. Okay, it is not mandatory that I follow D or F. Some people will start from D underscore. Some people will start dim underscore. Some people will start for fact table fact underscore, or some people will say F underscore. Say only thing is in your project what is the naming convention you are following. So based on that you can understand dimension or fact. Even sometimes you do not have any name to identify. So go and see the data in your table. You will come to know if the table having measures, you can say this is a fact table, and if the table doesn't have the measures, you can say it is a dimension table. So we already seen yesterday every dimension table, okay, when we are creating, we will have some different additional columns which are like surrogate keys, okay, dimensional attributes, natural keys and all. And also once you create a dimension table with all these columns, okay, so when it comes to the loading, how do you load data? So two topics we have discussed yesterday. One is, now we know what dimension contains, what fact contains, and when you put together star schema, Snowflake star schema or multi-star schema, so that is all over. So now a reality. So now I am creating a dimension table. So every dimension table may contain, okay, these type of columns. Okay, so why we have to create these kind of columns? Yesterday we discussed, okay, there is a purpose actually. You can create without all these, you can keep only whatever wanted columns you want, you can keep, but you will have some technical challenges. So that's why when we are creating a dimension table, in the dimension table we will create all these columns, okay, and then we, in order to load and then read the data perfectly. And at the same time, once you create table, dimension table with all these columns, the next is I want to load data. So I have created a table with all these columns in data warehousing database. Then I want to take the data from the source systems or OLTP system and load into warehouse. Okay, so when you are loading data into warehouse, okay, into dimension, loading means taking data from the left side source systems, okay, and then inserting data into your final data warehousing dimension table. So there are a couple of approaches, type 1, type 2, type 3. These are the three methods we have to load data into dimension table. That is, I have seen type 1 means new record, okay, will insert, and changed record will update it. Okay, so because of this nature, okay, we will not have the historical information available in the dimension table. Okay, so we have seen if it is a type 2, new record will be inserted and a changed record will be again inserted. Okay, because in the type 2 we will have the historical information tracked here. Okay, we will have the historical information as well. Okay, so only thing is after inserting changed record also, we'll do some extra activities like historizing, okay, flagging the records, okay, that we have seen detailed yesterday. Okay, and type 3 we have not discussed, we'll go now. Okay, and type 3 is a partial history. Okay, we'll maintain history in a separate column. We'll come to that now. Okay, so just to find a fast recap, type 1. Type 1 we know new record insert, changed record update. Okay, and what are we doing? Okay, there is, okay, day 1 there are no employees, there is no data. So in this table and this table you have the new records. So I am going and taking and inserting into table 1. Okay, whatever table we have created. So this is the new, this is the new, I'm inserting. Okay. And after next day, there is one more customer joined here. Okay. I'm taking this data and again inserting into this particular table, because new record always insert. Okay. Fine. So far we have seen only new information you have inserted. So now there is a change in the address of this particular customer. So when there is a change, if it is a type 1, what we need to do? Changed record you need to update. So take this changed record. So now previously, so this customer was in USA, now moved to UK. So there is a change in the address. So changed information as per the type 1, we have to update it. So we'll take this record and then we'll update here. Take this information, update here. So with theoretically we are talking, but when you are developing a code, use any ETL software code and then develop it, either Informatica or DataStage. So maybe here we will be learning about Informatica. So we can use Informatica to identify new, change the information and take that piece of information and go and update into your target table. So this is the type 1. So it will continue in the same way. Okay. In this case, okay, there are changes here. There is a new information here. So we'll go and update here or insert here. It will continue wherever, anywhere in the world. Type 1 means new records will insert. Changed record will take and then update here. That's what we do. The type 2, there is no change. Okay, new records will insert, but the changed record will do something else. Okay, so generally we have seen, like, I can go and take directly put here. So new records insert, changed record also insert. But when you start inserting the data into this table, okay, you will have duplicates in your customer ID that we have seen yesterday. So as an alternate, what we'll do, when we are creating a dimension table, apart from whatever columns we are storing here, let's say, what is the data we have in our source system or a OLTP system or in a bank? We have customer ID, name, okay, marital status, address, status. You can have, it is a sample data. You can have 100 to a minimum in one dimension. You may have like 70, 100 columns. That is a common in a data warehousing. So if I only previously in a type 1, so far whatever table I have right side, in that I have only these columns. I don't have anything. And I didn't have any problem also, because new record inserting, change record updating, even I didn't have any problem. But now when I am loading data in a type 2 method or type 2 style, so new record insert, changed also I am inserting, because see C1, okay, changed address from New York to Boston. So you will have two records for same customer. C1 previously was staying in New York and now currently staying in Boston. So you will not have a clarity what is the current address, okay, and even if I want to find out, okay, if I want to create a primary key, so I cannot create a primary key on this column. And even somebody asking, tell me what is the current address of the customer. I cannot tell you, because it is a New York we have, Boston we have, and even if you have one more also, I can have one more. Okay, I will not have any clarity. Okay, what is the latest address, and also what period, what time, okay, and what was the address of this customer also. It is very difficult to track from here. So that's why, keeping all these lessons learned, when we are creating a dimension table in data warehousing table, what we will do, apart from these columns, okay, we will also keep some extra columns. Okay, that is for the technical maintenance purpose. Data for all these columns, if you see, will be coming from here, but whatever columns additionally are creating, so these are very important for the ETL people. Okay, because you are the one that are going to load data into this table, okay, and generating the information for this. I will take all this data from here, whatever is there as it is, but these columns data we will generate using our ETL software, Informatica DataStage or ODI. Okay, so to do this, what we will do, so the column which is surrogate key, we already discussed. Okay, surrogate key is a primary key column or acting primary key column in your dimension table, because your customer ID, okay, will not be in a position to act or create like a primary key, because we are storing duplicate record. When there is a change, so customer C1 is there, again there is a change for the customer. So customer address may change 100 times. So if I keep same C1 100 times, I cannot create a primary key on this one. That's why we'll create one extra column called surrogate key. Okay, why it is called surrogate key? Also, it is a dummy column which is acting primary key. It is not reality. Okay, we are generating. So whenever we are inserting data into this table, every time we'll take the data from this and put it here. Additionally, in the surrogate key column, okay, we'll keep generating 1, 2, 3, 4 continuous serial numbers. And ETL tools will support, okay, ETL softwares will support this kind of generating the numbers, or you can use the database sequences. Okay, using that you can generate the numbers, and that way I can make this column as a primary key. Okay, then coming to the current flag, so to indicate that what is the column out of all these records, which is the latest record and which is the old record. So currently we have only C1, C2. There are two customers. There is no repetition also, because just we have to. So for this C1, this is the latest record. For this C2, this is the latest record. Okay. So and if it is the old record, we will make it N. Okay, that we'll see later. And to indicate when this record has been inserted, but how long, okay, the effective of this record. So to indicate that in effective from date to date columns, we'll keep, okay, when you have inserted this record and how long this will be reality. So can you tell me at this moment, okay, now she is staying in Hyderabad. So can we expect that how long she will be in Hyderabad? Nobody knows, because unless there is a change, she herself doesn't know how long she will be in Hyderabad, because unless something comes and something activity happens, so when that reality comes, when she really move, then we'll change it. So that's why in a effective to date, we'll keep dates called high dates. High date means a date which generally you cannot, okay, expect or anticipate. So most of the times in data warehousing, biggest date in your calendar will call as high date. What is the top biggest date in calendar? 31st December 1999 is the highest. After that we don't have anything. Even we cannot imagine anything after that also. That's why those dates will call as high dates. Or some people will leave it blank also. Blank also will do, or you can keep the high date anything. Okay, that we'll see in ETLs how to will load it. Okay, so in this case we are inserting the data only, because this is the new records, new customers I just inserted. Then once you insert, your data will be looking like this. After a couple of days, okay, there is a change, okay, in the customer C1. Okay, previously this person was in New York and now change the address to New Jersey. There is a change in the address. So when there is a change in the type 2, what we need to do? Change the record also we have to insert. Okay, and we have to do something. So now I am taking this data because there is a change and inserting here. Okay, so when you insert, we have seen some rules. New records when you insert, along with you generate surrogate key. Okay, a new number, continuous number. Current flag. So being this as a current record, so I am keeping Y. And effective from date to date. So on day 5th, because when this request has been come into bank on 5th day. Okay, day 5th. So on day 5th, so I am keeping day 1, day 2, but in a reality will keep real dates. 31st December, some year you will keep real dates. Okay, so here D5. Okay, and then how long? I don't know, because now she moved to New Jersey, but I don't know how long she will be in New Jersey. Okay, this is fine. But when you keep the data like this, what is the problem now? This is it indicates that Y indicates that the latest record. So we have Y here, okay, and we have high date here also, and the previous record also having Y and then high date. But this record is no longer latest record for now, because it has been like she stayed in New York from the day 1 to day 4 only, because she moved to New Jersey on day 5th. So How long she stayed in New York? Day 1 to day 4 only. And now she is no longer in the New York. So that's why after inserting, so you can see changed record also insert, then versionize old records, because we have some old records. Go to old records, okay, make current flag n because it is no longer current record, and then effective to date. Okay, so this record was effective up to day 4 only, because after day 4 and the new information has come to this customer. So that way you take any type 2 dimension table, okay, and it will be looking like this. Sometimes in place of yn, some people will also keep 1 and zeros. It is your choice. Y indicates latest record, n indicates old record. So if you don't want yn, you can also keep 1 0. 1 indicates latest record, 0, it is your choice. A, B, generally what is good is Y or N, 1 and 0 are good. So generally ODI people, Oracle Data Integrator people, when they are loading, they use 1 zeros. Okay, they have some built-in programming code, and all other people like Informatica, DataStage, they will use Y and N. So, but there is no difference actually. It is your choice. Okay, so this new record insert, change the record also insert, and if you leave after inserting, if you keep as it is, you will have a technical challenges. Okay, what time, what and all. Okay, so now we'll go and versionize the previous record also here. Okay, so putting all together, okay, so this column is called surrogate key, the first one, okay, and this column is called current flag, this column is called effective to date, and this column is called effective from date. So we know why we are building, why we are creating these columns. So I can, using these columns, I can find out, okay, this is for primary key purpose. So this will tell you which is the latest record. So once have this table, if somebody asking, please give me latest address of all the customers, go to this table, select star from table where status, current flag equal to Y. So it will only give the latest records. If somebody asking, I want to know on day 3rd, what is the address of, on day 3rd, whether a customer married or not. I want to know that information. Still I can get it. Select star from this table where day 3 between effective from date and effective to date. So it will directly take you. So day 3 will fall under which bucket here? It will be falling under this bucket. So it will give you, okay, it will take you here, and in day 3 she was in New York and then unmarried. So that way we can go on. We have the current data, we also have the historical data, and we can also go and find out what time, what information was there for a particular customer. So this is all reading is a reporting people duty in generating, when generating the reports. So they will write these kind of queries. ETL people, when you are inserting, you will keep these numbers, you will ensure that your data loaded this way. When reporting people are reading, okay, you will be writing the SQLs to read latest, to read old, as on the date, okay, whatever information you are looking. So that way your table will be there, and then you will be reading the data or loading the data. So this is all we know. But you see, there is one very popular interview question. Okay, when we are building the dimension table, you have seen what is surrogate key is a primary key. It is a dummy column, and current flag will indicate you latest old, and effective from date to date will tell you till what time to what time your record was effective or valid. And there is one column I mentioned it as a natural key. It is very standard interview question nowadays. What is a natural key? Natural key is nothing but a key, a natural primary key. Okay, what is natural primary key means? Say when you take this one, Okay, so now I am back. Okay, so what is a natural key means? Okay, this is where yesterday we stopped. This is all kind of a repetition. Okay, a primary key column in a OLTP system. Okay, is maybe in case you want to define in a technical definition. So all these notes I will give you. Don't worry about the definition. The way how exactly you have to represent in your interview, I'll give you notes, one liners. You can take it from there. A primary key column in a OLTP system or a primary key column, okay, in a source system, okay, is called natural key. So if you take this example, actually I must create a primary key on customer ID, because if you go to any bank, do you see two customers having same primary key, same customer ID? If you give, it's gone. And we cannot see two customers having same customer number or same account number. At the same time, if you go to any university, you have two students. There cannot be two students having the same rule number. Okay, if you are giving, then you are gone. Okay, so generally, naturally, when you are developing a software for the day-to-day purpose, let's say you are running your examination system. So I am running my bank branch, or I am running my telecom billing system. In that system, so those are OLTP systems for us, or those are the source systems for us. In these systems, we can create a primary key. If I go and see this table, when I'm in, these are all OLTP systems for us. In the OLTP systems, I can create a primary key on customer ID. If I don't create, you are not in a position to create primary key in the source system on customer ID, means you are in a danger situation. Okay, because I cannot, because what is this? It is your OLTP system. If you go to ATM machine, whatever data you see, that is this system, that is your OLTP system. Okay, so if two customers having same account number, you are gone. So that's why in a OLTP system, in a table, whatever columns you use as a primary keys, okay. So when it comes to data warehousing, I may not be in a position to use as a primary key, because of the type 2 nature, we are same record inserting 2-3 times, because this is old record, but this is a new record. But in this OLTP systems, you will not have a duplicates. Okay, there will be strictly, there is a duplicate means you are gone. Okay, strictly in OLTP systems, you will not have the duplicates on customer ID. Examples, let's say there is a product, you go to any shopping mall, there is a one product, for every product there will be unique number. Go to examination, student roll number, you take your mobile. So can we have, okay, in Airtel, okay, can we have same mobile number for two people? I cannot have it. Okay, so those are generally, okay, primary keys in your OLTP system. When it comes to data warehousing, I will not be in a position to use as a primary key, because of, if it is a type 1, somehow we can do, but in the type 2 strictly we cannot. That's why a primary key column in a OLTP system is called as a natural key in data warehousing. So what is the natural key here? Customer ID, because in OLTP system, customer ID is a primary key. Why they named as a natural means naturally, okay, when I am running a business, naturally every customer should have one customer number. Naturally every account should have one number. Every student should have a roll number. Every product should have one product number. Okay, but in data warehousing we want historical also. That's why we are keeping repeated data. Because of that, I may not create a primary key here. Okay, so this is so very common in this topic. Two interview questions, very standard. What is the surrogate key and what is the natural key? Natural key, in technically, if you want to define, a natural key is a natural primary key, or A natural key is a primary key in a OLTP system or a source system. So that way you can define it. Surrogate key is a acting primary key. So you see the difference. Why we are calling as a surrogate key? We discussed, right? If any child doesn't have a mother, father, there will be somebody to take care of them. So those are called surrogate father, surrogate mother, or surrogate parents. In the same way, I have a customer ID, but it is not in a position to act as a primary key because of the repetitive nature. So we are buying one more extra column. Okay, means we are creating, putting some numbers and making use of that as a primary key column. So this is all, okay, story about dimension. You go anywhere, this is max about the dimension table. Okay, and sometimes, okay, you will have, okay, not nowadays, in the older days, we used to have one extra column. Okay, so this is the same thing. If there is a change, okay, previously we already discussed, but just to show. So for example, now assume that previously you see, so this is unmarried, okay, so this is also unmarried, but now assume that, so this customer got married, okay, means again there is a change. So again what we will do, I will take that and then keep it as a new record, okay, and I will make previous record as N. So now customer C1 now is present 3 times in my table, and this is the latest record we are keeping as Y, and this is high date, okay, and the surrogate key, and now this is no longer current, this is no longer current, okay, so we updated because I am inserting on a day 9, okay, day 10 I am inserting, okay, I think it should have been day 10 here, okay, so I am making all N. So if you want to know what is the latest address of the customer C1, you keep current flag equal to Y, and you will get 2 records. One is C2 this record and C1 this record. These are the latest address, latest information of the customer, and this is no longer, and this is no longer current, this is no longer current, and this is a primary key, this is a natural key, and this is how a dimension type 2 table or typical dimension table exists in a data warehousing. Okay. In addition to this, it is not important, just for your information sake, sometimes in dimension table we will also keep some extra column like version. What is version means? Whenever there is changes happening for customer, okay, C1 or a C2, see in what order it has been changed. Okay, now if you see C1, how many records we have? 1, 2, 3 records we have. So you will have serial number like 1, 2, 3 for C1, and if you go to C2, there is only one record, okay, so it is having only one time. C3 again is only one time, okay, one only. If I add one more C3, so you'll have 1 and 2. Nowadays we are not required because you already have the surrogate key. We are generating continuous serial number, so I can survive with that. So in case you do not have surrogate keys serial number generated, then we can make use of that. Okay, not that much required actually. In case by chance if anybody asking an interview what is version means, you can just say it is a order of the columns or order of the rows in which they have changed. But generally we can survive with surrogate key, not required. That's why you will never see this kind of columns nowadays. But in case if anybody asking, or if you see this kind of columns, they are meant for seeing the order, in which order. Even I can get that information even with the date also, because we know the date in how we are inserting, okay, and we have also surrogate keys. But in older days, okay, to get the things in an order by very quickly, people used to create, but nowadays not much required. So that you can completely ignore. The only thing is I am just telling in case if anybody referring that, you can use it. So this is all about type 2. So type 2 is important. If you know type 2, you can manage everything in data warehousing, loading point of view, you can manage everything. So now type 1, okay, new record insert, changed record update, no history. In type 2, new record insert, changed record also insert, okay, because of that you will have a version, previous, current, all the information. When it comes to type 3, so type 3 also very rarely you will see type 3 tables, okay, But for interview point of view important, what is type 3? Because it is the behavior of the type 3 is completely different. So that's why people, just for matter of interest, they will ask you. Okay, what is type 3 means? Type 3 will maintain history partially, not type 1 no history, type 2 full history, because a customer changed the information 100 times also will have in a table. But in the type 3 will maintain history, partial history means one time history or two time history, and even that history also will create in a columns, okay, not in the rows. Previously every time when there is a change, what are we doing? A new record coming. But in this case what we'll do, so take this example. So we have one city, okay, city ID, city name, okay. So we know that city ID C1, previously Madras, okay, was the city name, and later it got changed to the Chennai. So in the type, if it is a type 3 dimension, what are we going to do? We are not keeping, let's say if it is a type 1, what we'll do? Sorry, type 2, city 1 Madras will be there. We'll have one more record, city 1 Chennai, 2 records will be there. But here we are not doing that way. Okay, so what are we doing? Assume that in the day 1, sometime back, okay, we have a city Madras. So this data I want to take and then put into this dimension table. So nowadays you never work on, just to theory understand how it works, okay, because it is nothing great in this one. So if it is a type 3, again we'll create one table, city ID, city name, fine. I have taken this data, inserted into this. After that what happened? There is a change in the city name because Madras name got changed to Chennai. So what I am doing here, previously if it is a type 2, what I will do, I will take this insert as a new record because we are inserting. But in this case I am not inserting. I have created separate column. So here we have one column previously, I have one column, separate column. So you will have one column city name, current city name, original city name, and this is the previous city name. So always when I am creating a table, okay, I will keep two columns. Okay, so whenever there is a change, I am moving. Previously we have a Madras here, city name. So this Madras information, okay, I am moved to previous column, this column. So Madras moved from here to here, and whatever is there, this has come to this particular city name. Okay, so now this way you have the history previous, but how we are maintaining history in a separate columns. So to explain very easily in a type 3, what is type 3 means? We will maintain history in a separate column, not as a row. If it is a type 3, what we'll do? Let's say same information if you are doing in a type 2, what we'll do? Let's say I have a city, let's say Madras. If I am building this as a type 2 dimension table, so this is how I will do it. Okay, so first time there is a city Madras, so I am inserting it. So later this got changed to Chennai. If it is a type 2, so I will take this information and I will insert it as a new record. Okay, 2 records are there, type 2, because any change also will insert. So we will have 2 records. But in the type 3, what are we doing? I am keeping city ID. I will create 2 columns. Always I will say current city name and previous city name. So if you take Madras from the beginning, if you take, now I am loading into type 3 table. So first time I will take this and then I will keep into this table. So there is a Madras, I will take and then I will keep into this table here. Now after a few days, this Madras information, Madras name changed to Chennai. Okay, so in this case what I will do, I found that there is a change in this information. So I'll move this Madras to previous city, and then I'll take this and then keep here. Okay, means this is a type 2. We'll maintain history in a separate record. This is a type 3. Okay, we will maintain history in a separate column, not as a separate record. Okay, so here is a row and separate. Fine. Now assume that later this Chennai has been renamed again after few years to New Chennai, like New Delhi. So what happens in a type 2? I don't have any problem. I'll take and then keep here. Because 100 times, 1 lakh times also I don't mind. I'll take and then insert, keep inserting. Inserting a record is, there is no limitation. But when it comes to here, there is a change again in the city. So what I have to do? I need to move this Chennai to Madras. Okay, means I will be losing previous history. Okay, and then I am taking this Chennai, New Chennai, and keeping here. Okay, that's why type 3 is called partial history. Okay, and type 1, type 2 keep continue, but in the type 3 we will decide whether you want only previous, latest, current, and then previous. Okay, or even sometimes if you want to last 2 also, you can create one more column. Maximum how many columns you have, only those columns history only you can maintain. If it is 100 times changing, you cannot maintain here. Okay, so that's why type 3 you will see very rarely. Also when we create type 3, we will create type 2 when we want current and history, but we will create type 3 when we are always looking for the latest only. Say for example, I'll tell you. So this particular person, now she is in Hyderabad and she made some transaction, she moved to Bangalore and she made some transaction or purchased some item. I want to know, when she purchased this laptop, I want to know what was the address. Because at that location, okay, what is the tax? Okay, maybe let's say now she moved from India to somewhere else. So when she purchased one item in India and she purchased one item in US. So US tax will be different, Indian tax will be different. So I want to find out when this item purchased, what was the location. So I want to go and track previous history. I want to know that address. So now let's take example of city name. There is Madras and now become Chennai. Do you really know, do you really care about when it is moved to Chennai, when it is changed to Chennai, okay, how long it was, name was Madras? You will not get any meaning. So name is name fixed, that's all. Your name was Madras, now it is named Chennai. I don't care when it is Madras, when it is Chennai. I don't care. Really, I don't need it. So only just information sake we are maintaining that way. Okay. So it was previously this name, currently this name. So that at least you will have some clarity information. So that kind of okay purpose we can use type 3. So this is only theory interview. Very rarely you will see this kind of dimension. Okay, but very rarely you will see type 3 kind of dimensions in a reality. Of course, maybe for one project, 1 or 2, or sometimes you will have a 0. Okay, so this is how your type 1, type 2, type 3 comparison. Type 1 no history, type 2 full history. Okay, history is maintained in a rows. Type 3 partial history and history is maintained in a columns. That is the difference. I will have a differentiation sheet also. I will share you soon, maybe once we have all these classes, so that you can have a clarity. So now this is all about 1, 2, 3, and there is something called type 4, type 6 also we are discussing nowadays in advanced modeling and advanced data warehousing projects, bigger data warehousing project, and that I will discuss in an advanced topic, because this is very important, that if you don't know also you can manage, but if you don't know this you cannot manage. So that's why that we'll discuss in advanced classes. Okay, I don't want to mess up everything. So this is all about the dimension load strategies. Okay, now, okay, the next is, okay, if you see this project, we have so many type of dimensions. So there are like some hundreds of dimensions we have here. So to easily identify the behavior of the dimension table, okay, so every dimension table, okay, will categorize, will group, okay, this is this type of dimension, so this is this type of dimension. So to easily, okay, understand the behavior of the dimension tables, okay, so that's why, okay, when the dimensional modeling, okay, every dimension table, so will name with some names. Okay, at this moment it is not required. Again, this will discuss in an advanced class only, because it is all theory. Okay, unless you see really working on the tables, it may not be that much effective to learn. That's why once we complete the course, again I will come and then recap all with the practical examples, and also during the course, okay, wherever we get this example, I'll try to show the practical, because even if we discuss, it will be like Greek Latin for you. Okay, so these are all different type of the dimensions. I'll just give a glance of, okay, for 1 or 2 minutes, okay, just to have a feel of, and very detailed we can discuss in a later advanced session. Okay, so first thing, very commonly, okay, used word, okay, is something like slowly changing dimension. It is popularly known as SCD, slowly changing dimension. Okay, and also reverse to that slowly changing dimension, we have something called fast changing dimension, or fast growing, rapidly changing, or monster. So all are synonym words. Okay, and confirm dimension, role playing, bridge, degenerate, identity. So right now you may not be understanding, because first of all we are not seen, at least created one table, loaded and all. So that's why I'll just give a glance, and practicals will go and see later. Okay, so first, what is slowly changing dimension means? You create any dimension table. In this table, if the information is keep changing very fast, very slow, okay, and mostly 60% or 70% of the dimension table in data warehousing files are slowly changing. That's why it has become a common word in a real life. Everybody, the moment when they talk, they are not talking about the dimension. They only talk about slowly changing dimension. Okay, it has become a habit that when we are referring a dimension, we are just referring it as a slowly changing dimension only, because most of the dimension tables are slowly changing only. Means in a table, okay, when you are loading data into this table, the changes into this table will be slow. Means changes will be definitely there, but they will be slow. Example, I am building one customer table. Okay, I have some customers and then their marital status, address. Once somebody take an account in a bank, okay, and then once I keep that information in a table, how frequently this information may change? Think about how frequently you will change your address. Let's say if there is a person, if you settled in Hyderabad, there will not be any change. Even if it is changing also, it will never change daily, or it will never change monthly. Okay, in very rare case, you will have your changes. Okay, changes in these tables will be very slow. Okay, that's why the table will be very growing very slow, because when there is a change only new record will come. Okay, so once the data inserted into this table, the changes in the table will be very slow. So that's why they are popularly known as slowly changing dimension. So most of the tables are slowly in nature. So that's why people will start talking about slowly changing dimension type 1, slowly changing dimension type 2, slowly changing dimension type 3. Okay, but it is one type of the table only. Now, if you go to other, okay, fast changing. What is fast changing means, see, customer dimension table, I have a surrogate key, customer ID, name, marital status, address. So how many times a customer will get married? Once. Okay, in worst case, okay, 3 times. Okay, maybe means even if you take the life cycle of the customer, if I am keeping only marital status, address, for one customer there will be only 4-5 changes throughout the lifetime. Say same table I am planning to keep in the same table. This time I am planning to keep age. I am keeping the date of birth and then I am keeping the age also. Okay, means for every customer what is the current age I am calculating and keeping into this table. So I am calculating the age in the terms of the weeks. Okay, how many weeks of the age, or you can keep the age in the years or in the months. So right now I am keeping the age in terms of the weeks. Okay, what is the age in the weeks? Okay, 100 weeks or 200 weeks. So in this case what happens, every week there will be change for a customer, because your date of birth, okay, your age will be changing for every week. So definitely whether there is a change in the address, there is no change in the address, definitely there will be one record new coming into this table, because every week your age will be changed. So today, this week 500 weeks, so immediately next week it will become 501. So like this we are going to keep. So in case, okay, whether you decide whether you want or you don't want, I am just giving example. In case you are, sometimes some of the columns will be changed, okay, very frequently. So let's say if I keep age in the days, it will be changed every day. Okay, for every customer there will be one record for every day. So this will make your table grow like anything. Because of this, it is fastly changing. And in the same way, okay, this is also a couple of other examples. Okay, product prices and all that. Okay, so what are the other common, okay, fast changing dimension? Okay, so your currency conversion, the best examples are currency conversion, share market prices, and your weather information. So we are building a dimension table for, okay, currency conversion rate. So I have some rupees, I want to convert to US dollar, or I have some US dollar, I want to convert to Indian rupees. So this currency conversion rate sometimes will change 10 times in a day, okay, or sometimes once in a day, but nobody can predict. It will keep changing. Okay, so because of that, whenever there is a change, I am keeping inserting. So that's why, because of this behavior, so your table volumes will be growing. Let's say I am planning to build every 1 hour, what is the current weather of a city. So weather definitely will changes, okay, every 1 hour, okay, even minutes also it will be changing. So some people who are looking for the weather, let's say there is one, the scientific development organization, so they are looking for the weather forecasting. So if you are capturing, definitely that will be keep changing for every week. So share market prices, couple of examples. So this will make your table will grow continuously. So these kind of dimensions are fast changing. So the percentage of the table in your data warehousing project of nature of this will be 1 or 2%. That's why you don't need to too much worry. Okay, but this will make your table growing like anything. Okay, so that's all practicals we'll see later. I'm just giving example 1 or 2 which are important. So slowly changing dimension, we'll keep talking, and fast changing dimension in a polished word. What are fast changing, fast growing, rapidly changing? Okay, the polished name in a data warehousing for this dimension is a monster dimension. Okay, it will keep changing, keep growing. Okay, so anyway, we'll give more examples in advanced classes. Okay, and there is another important one. Okay, we'll be keep talking something called confirmed dimension. Okay, so if you recollect, okay, when we are discussing about the Snowflake star, sorry, multi-star, you have seen one diagram here. I have one fact table and I have another fact table. Okay, so I have one dimension, it is common to this fact table, this fact table. So blindly, whenever you see this kind of diagram, that dimension you can say confirmed dimension, just to easily identify in a diagram wise. Okay, so what is actual meaning of the confirmed dimension is, A dimension table which is shared across multiple fact tables. Okay, for reporting people, very, very important. Okay, and we'll discuss anyway later. Okay, just to give a glance, and a dimension table which is common or which is shared across multiple fact tables. See here, I have one fact table. Okay, credit card balances I am storing. I have another fact table. Okay, saving transaction. So here I will keep only my customers who are having credit cards and what is their current balance. So this is another fact table I am storing. Okay, customers who are having deposit or saving accounts in the bank, what are their transactions? You can imagine. So one customer may have credit card and also saving account. So some customer may have only credit card. Some customer may have only deposit saving account. It is all your choice. So see here in this example, customer C1 having credit card and also customer C1 having deposit saving account. But C2 only have credit card, C3 have only saving account. So but when I am creating this table, since it is common for both tables, I will keep all the customers data in this table. Generally that is integrated. Okay, C1 is there, C2 is there, C3 is there. So if I want to know what is the name of the C1, I will use same table. If I want to know what is the name of C3 also, I will use the same table. So this kind of diagram is easy. One dimension table shared across multiple fact tables is called confirmed dimension. So these are very important common. And apart from this, a lot of things are there. We'll discuss in advanced classes. Okay, and these are very important for interview purpose. There will be 3-4 questions from this topic. What is role playing dimension? What is confirmed dimension? What is master dimension? Okay, and what is degenerate dimension? What is all this? Okay, we have the examples, everything we'll see in advanced classes, because it at this moment it will be tough for you to understand. Okay, so now that okay, we know dimensions, loading, type 1. Just to recap, what are the topics you have seen was star schema, we know, Snowflake, we know, okay, and dimension components also we know. Okay, and load strategies, that is type 1, type 2, type 3. Okay, and very detailed types of the dimensions still pending. Okay, I just give a high level overview, 1 or 2, because at least we will be keep hearing about. Okay, and we'll continue this in a advanced class. Attend, we'll get appropriate time and then we'll discuss detail about that one. So now we'll jump on to fact table, because we are not seeing anything about the fact table. Again, this will be important for ETL people only. Okay, so at least we know what is dimension table, what columns will be there, how you load data into dimension table, and how you read data from the dimension table. So putting current flags, effective from the, just simple. Coming to fact table, what are the components of the fact table? Maybe I'll take another 5-10 minutes. Okay, then I can wind up. Similar to how we are loading, okay, dimension table, fact table, dimension table. So fact table also, okay, will have some columns. You take any fact table, okay, you will have some set of columns, because so far we know, okay, fact table contains measures and foreign keys of the dimension tables. Okay, so every fact table measures, okay, or you can call it the metrics or quantifiable columns. Okay, this is a numerical, like quantity, price, okay, number of customers, number of products, all numerical column, and you will have the foreign keys. Okay, because without foreign keys you cannot join fact table with your dimension table. So that is the second we already seen. And you will have some separate columns in a fact table called degenerate columns. Okay, that we'll see how it works. So what is important now is the measures also, maybe for interview purpose, how many types of the measure, additive, non-additive, semi-additive, that also we'll see how this works, what is this concept. Okay, so to understand everything, okay, first we'll see how we load data into fact table. I'll just give and then recap tomorrow also. Okay, so let's say so far we know this will give you complete clarity about your data warehousing project look and feel. So because we are just reading and loading, this will give you, okay, complete what will be there in our warehouse, how the data you will take and then put into your warehouse. Okay, so now day one, okay, now again I am taking one small sales, like it is a online retail shop, just example. In the online retail shop, whenever you go to online, okay, trying to purchase item, okay, your website will show list of products from this table. What are the products you can buy from the shop? And whenever you are planning to buy, it will ask you to get yourself registered, your address, your credit card and all that. You have to get registered. Okay, once you get registered, okay, you will be member of that website. Then you can go and buy item. Okay, so this is your online shop, okay, OLTP system. So whenever you are making activities, transactions in your online website, okay, a lot of things will be there. I have taken these two. Okay, say for example, now day one, okay, I have created a table in the website. You are planning to buy one Dell laptop. You search and that information is there. In the website, it will show from this table that, so we are offering Dell laptop. Okay, there is 1 year warranty period. Price is $600. And the warranty period for this Dell is 1 year. It is there. You searched it. It is there. So now you tempted and you are planning to buy. So then it will ask you, you get registered. Otherwise you cannot, because you need to get all your address and everything. So you went and given your registration. You completed registration. So when you complete your registration, the customer details have been entered into customer table. New customer, new product is there. Then you will go and then place a order. So I want to buy, okay, this laptop of 2 quantities or 3 quantities, pay the amount and all that. You will generally continue. Okay, so this is how your company works or your online business works. So generally, whenever this information is generated in your OLTP, so this will take and then load into warehouse. Okay, so now day one, product is there, customer is there, you registered now, and then you placed an order. So which one? For every order you will have one order number, okay, customer ID. Okay, so who is the customer buying this item? So C1 means, okay, Hasin. Okay, and which product? P1, okay, Dell laptop. Which day to day one? Quantity 2 and price is 600. There is no discount. So when you place a order, when you click place a order, I am ready to buy. So information will be generated like this. So any OLTP system, any company you see, you will see this kind of behavior anywhere in the world. This data we want to take into our warehouse. So generally, how do we take? Daily basis we'll take. On average, we'll take the data from the OLTP system to warehouse mostly in the midnight 12 o'clock. Okay. So every day once, or even sometimes 4 or 5 times also. Sometimes we'll take every minute also. That is all different story. But we'll take data from left to right. So when I'm taking this data from left to right, so what I will do, I'm creating, so this is left side is OLTP system of your company. Right side is my data warehousing tables. So to load data into warehouse, I'll create dimensions and fact tables. And then I'll take data from the OLTP to right side. So we already seen how to load dimensions, how to load any table from the left to right. So now here to capture this data and load into this table, have created one customer dimension table and I have created one product dimension table. You see, customer and product all are attributes. There is no numbers, metrics, quantifiable information. We don't have any numerical. So nothing. So you see, this is the table. Now I have some numbers. Quantifiable, quantity, price, sum of quantity, sum of price, sum of the discount, like this. Okay. So once I create the table, so generally it is maybe over experience will come to know which data will go to fact, which data will go to the dimension. It just on your experience will get it. But generally, blindly to understand, all the numerical quantifiable information will put into fact tables. Remaining all textual attributes will keep into dimensions. Okay. And always blindly remember, when we are loading data into warehouse, first we will load data into dimensions first. That is very common for ETL people, very straight away question. Tell me how you load data. Okay, this will give you complete clarity. Okay, I'll go detailed tomorrow. I'm just starting today. Okay, so I know, or we know that, okay, all the attributes, textual attributes should go to dimensions, and this should go to fact table, because we have the quantifiable measures here. This is your OLTP and this is your data warehousing dimension and fact tables. Okay. So now what I am doing, since there is a new customer, there is a new product, okay, because we don't have the data in a warehouse. So first I am going to take this data and put it into my customer dimension table. I am putting there, and product I am putting there. So I didn't put that current flag and all. Assume that they are there. Without that we cannot manage. Only thing is I did display the current flag effective from the to date. Assume that they are there. So here also assume that they, okay, but I have kept the surrogate keys. Okay, assume that backside they are there. Okay, fine. This is the customer I have inserted here. Type 2 I am following. So this is the product I have inserted here. Fine. Then when I am loading data, okay, then once you finish all the dimensions loading, then I will try to take whatever data I have to load into fact table, then I will go as a third step. Okay, so in the third step, what I am doing, I am taking data from the left side orders table, because these are the orders, and trying to put into fact table. So what you can see here, when I am putting data into fact table, okay, see 1, 2, 3, 4, 5, whatever columns are there, I just created all the columns. But when I'm creating the fact tables, what we'll do, in addition to whatever columns we have, remember star schema, what? Dimension fact table, primary key, foreign key. Who will be the primary key in your dimension table? Surrogate key is the primary key. Okay, so in this table, who is the primary key? Surrogate key. In this table, who is primary key? Surrogate key. Okay, so now I am taking this data and putting into this table. So order 1 O1, okay, and customer C1 and product P1, okay, day 1 quantity 2 and 600, okay, and description, okay, discount 0. While keeping the data, taking data and then keeping here, what additionally we will do? Okay, when we are loading into fact table, now C1, I will go to dimension table. When I am putting this record into this table, at this moment, what is the surrogate key we have for this particular C1 in this table, I will take and then put here, because primary key and foreign key. And at the same time, when I am putting this record here, for this product, what is the surrogate key? What is the surrogate key for this product? 1. I'll take this number and keep here. So this way it can help you to join your dimension to fact, okay, based on the primary key, foreign key. Of course, okay, even we can join with customer ID also. It will not always help. You will have lot of challenges later. That slowly will be come to know that. That's why if you see this diagram, generally just a reality, fact table, dimension, primary key, foreign key. So right now I am putting only 2 dimension. In case you have more columns, I can have one more dimension, I can have one more dimension. So these foreign keys also I can keep here. So that's why it is called star schema. Okay, every dimension table. So when you are loading data into fact tables, if you are a ETL guy, So it is your duty. So using ETL, when you learn Informatica, okay, so you are responsible for taking data from this and putting into this table. While keeping data into this table, you will also go and find out for the C1 what is the surrogate key, for this P1 what is the surrogate key in this table, and put here additionally. So that is actually primary key, foreign key. So why, okay, you will now understand generally why are we doing that. Okay, so now that is over. After 10 days, what happened? So previously we know what is this. We have one product, okay, one customer. So you place one order, fine. After 10 days, what happened? You went and online website, you searched that. Again, you are planning to buy same laptop. Now you went and website and search. What these guys have done? Previously, they have given 1 year warranty for the Dell laptop. Now they removed the warranty because of XYZ reason. Okay, now when I go and search in the website, okay, it says that for this laptop there is no warranty. Okay, and because of, since there is no warranty, okay, but still, okay, you are tempted to buy it. So generally here I need to keep 6. Since they removed warranty period, so I'm just making it as a $500. Yeah, this is a mistake. Okay, so now since they removed the warranty period, so that's why they cut down the price. Okay, $100 they reduced it. So in website it shows that. Okay, that is the nature of the OLTP. Whenever there is a change, they will go and make it update. That's all. Still you tempted, okay, because there is $100 reduction, but how you need that laptop. So you went, same customer who were previously purchased, same customer, you are the one. Again you are buying same laptop again. So when you buy it, okay, new order O2, C1, same customer, okay. And this time also you are buying same P1, but this time there is no warranty period. Okay, when, which date? Day 10. How much quantity? One quantity, price 500, done. You paid the bill, done. So when it happened? After 10 days. So now this data I want to load into warehouse. Okay, so what I will do? Customer, there is no change. Here also same thing, there is also same thing, there is no change. If you go to products, since there is a change, so I will take this and then insert it as a new record because there is a change. P1 500, so new surrogate key, okay, and all current flags, everything will be as usual, will be followed. Now after doing this, there is no change, so both are same, no problem. This, there is a change I inserted, so then I load into fact table. So when I am loading data into fact table, I will take this O2, this record, and then keeping here. So now C1, I will go here. What is the surrogate key now? Still it is 1 only, I will keep 1. For P1, I will go here. What is the current surrogate key for P1? 2 it is. Okay, because this is the latest record. Okay, so I will get this number and keep here, and remaining all as usual I will keep it. So now what is the advantage of this one is, say now, forget about this table. Now I give you this data. 3 tables I will give you. So now somebody coming and asking you, please tell me when this product purchased by this customer, whether there is a warranty period offer is there or not. You purchased P1 when? Sometime back. So now this guy is asking whether this guy, when he purchased, whether for this product there is a warranty period offered or not. Because sometime back we had a warranty period. Let's say this guy want to find out list of how many people purchased, okay, in a long back, and for which I need to support warranty. Let's say in India there are 500 laptops purchased. Okay, out of 500, how many still I need to give warranty period? If there is no laptops in India, okay, for which I need to support warranty period, I don't need to keep a service engineer in India to repair Dell laptop, or you know Dell repairing. If there is there, at least for the purpose of that also I need to keep one service engineer in India in stores. If there is no laptops purchased in India, okay, for which I need to give a warranty period, I can remove that service guy and then use it for different purpose. Just example. Okay. So that's why if you do not keep these values here, assume that you don't have this, you don't have this. So if you join this P1, okay, you will not have any clarity when you have purchased this product, whether you have a warranty period or not, because P1, both records are there. Okay, but we don't know what is exactly associated. But if you use this one for joining, this record will go and join with this one. So what it says that when you purchase this product, there is a warranty period 1 year. So this I will join with this record. So when I join this with, it will tell you that when this purchase, there is no warranty period. So I'll come to know there is one product for which I need to give a warranty, and for one product I don't need to give. So this kind of, generally data warehousing means this. What is analysis means this. This is how users will generate the reports and they will find out, take the decision. It is not like dumping the data and then reading. So they they run the business with a lot of this kind of analytics. Okay. So now across the globe, okay, Dell purchased so many laptops, and then I want to find out, let's say there is a country, Indonesia. Do I need to keep one service engineer in Indonesia? Okay. Or do I need to keep any spare parts in Indonesia, okay, to repair my Dell laptops? If I know that there is no laptop in Indonesia for which I need to give a warranty, so I don't need to do anything there. I just focus on the other activities. So this way the companies will run the business. Okay. So this is how we'll load the data into fact table. Okay. And I think it is very hectic for today. We'll continue this tomorrow. Okay. I'll try to recap tomorrow again and then we'll continue. But this is your the end result of your data origin, not the dumping the data. So lot of things we'll do, analysis, analytics. Okay. Everywhere. People who are working in a business, they know how effectively they want to use data, because you are not working in a company or not running the business, you don't know. But if you are working, if you are running a business, you know how effectively you want to use the data. Based on that, for that purpose only, we'll build the tables here. Okay. So rest will continue tomorrow. Maybe by tomorrow I can end these concepts. Okay, basic level. We'll start after tomorrow our ETL and reporting both. For you, I'll take a separate classes. Okay, thank you.